Ah, yes. Good morning, Jeff. Can you hear us? I think you are muted.
Sorry, yes. Good morning, hello.
Perfect.
Sorry for the delay.
Hi, Jeff.
No worries. Actually, we just changed the meeting link 20 minutes ago, so sorry for the inconvenience. But
No worries.
good morning again. Thanks for joining us for this Q&A session today. I am Emre. After working in Silicon Valley for 7 years at Google Quantum and Liftoff, I moved to Ethiopia and founded A2SV after Silicon Valley with this amazing group of people. And at A2SV, we train top software engineering students in Africa, connect them with opportunities at Silicon Valley, and bring them together with Silicon Valley professionals to work on socially impactful projects for Africa. And currently we have 52 students, 4 full-time, 3 mentors, and 3 advisors. And our Q&As are bi-directional, meaning feel free to ask us any question at any time to any of us. And now I'm going to leave the mic to Isaac and Lydia.
Hi, Jeff. Thank you very much for taking time to chat with us today, especially at this hour. And it's really nice to get to talk to you at this time. First, let me introduce myself. My name is Isaac, and I'm a 5th-year software engineering student here at Addis Ababa. And here's my colleague, Lydia.
And my name is Lydia Gashatana, and I'm also a 5th-year software engineering student at Addis Ababa University. And we'll be conducting this Q&A interview with you today. So during this session, we'll ask you questions about yourself, your career, your life, and Google. And you can steer the conversation in any direction you want. There's no hard boundaries.
Yeah, I hope you enjoy this.
Wonderful. Yeah, and I can go a little late since we're starting a bit late. So,
okay. So I guess we can jump into the questions. So most of us know who you are, but could you please tell us a little bit about yourself? Perhaps about how you got connected to A2SV and ended up in this Q&A with us.
sure. The connection to A2SV is through Emre. So Emre and I actually play soccer together. We're in a soccer league that I've been playing in since I moved to Silicon Valley. So it's a 25 years and over league. You know you're old when you're in a league with a minimum age instead of a maximum age. And the 25-year-olds seem faster every year, but I've been playing in that league for maybe 25 years at this point, so it's a lot of fun.
Yeah, that's awesome. And
yeah, go ahead.
You were saying? Sorry.
Go ahead.
Oh, okay. You're one of the very few people that joined Google at one of the beginning ages, essentially since it was a 1-year-old company, I guess. And what would you say is your most gratifying impact that you've had on the life of the company? And like what interested you back then and what interests you right now as well?
Yeah, I mean, I've worked on a lot of different things over the years. I think probably the first 4 years I was at the company, I was working primarily on our sort of crawling, indexing, and query serving systems for our search engine. And that was the only thing Google did at the time. And that was a lot of fun because at the time the company was growing very fast in terms of like adding employees, but also our traffic was growing very fast. So you think about a search engine in terms of how many queries per second you're getting or queries per day or whatever. And then another way you can think about a search engine is you'd like to be able to provide answers to any question someone asks. And one of the ways that you can do that is make your index of pages bigger. And obviously, it's very hard to provide an answer you don't have in your index. And then another aspect that you can think about the engineering challenge of building a search engine is like how quickly can you update the index, right? It's much more useful if you could update, some of the index every minute when those pages change, because it's like a frequently changing news site or whatever, rather than say once a month, which is what we were doing maybe once every month if we were lucky, when I started at Google. And so you think about kind of the inherent challenge of a search engine as kind of the product of those things. Like you need to handle a lot of queries per second per day. You want to index as much stuff as you can. You want to update the index as often as you can. And then also you want to apply kind of more sophisticated algorithms for deciding which results you're going to show in response to your query. And the more computation you can apply to that problem, generally the better your answers will be. And so the first 4 years I spent kind of really working with a small set of people, really dramatically redesigning the system every year or so. And this is always challenging because you have a live system that is serving tens or hundreds of millions of queries per day, and you're also then trying to like completely change it under the covers while no one notices. So I would say that's one that it doesn't get a lot of discussion externally because we haven't published papers about it or whatever. But it's pretty exciting. We went from an index of maybe 30 million pages when I started, updated every couple of months, to one that is tens of billions of pages, serving 1,000 times as many queries per day and being updated every minute or so.
That certainly seems interesting. And like you said, you've worked on optimizing search requests, and I know you've worked on optimizing microprocessors and compilers as well. What was the transition to AI like? Currently, you're the head of AI at Google. What was it like to transition to AI, or was it even a transition at all?
Yeah, so I actually gotten interested in neural networks as an undergraduate when I was at university, and one of the things I had to do to graduate was to do a kind of a senior thesis. And in one of the classes I'd taken, there was a few lectures about neural networks, which at that time, this was kind of like 1990, there was a wave of excitement about neural networks and what they could do in terms of like solving interesting problems. But it seemed like we just didn't have enough computational power at the time to like make them solve real world problems. They could solve kind of interesting toy-sized problems in kind of cool ways. And so I got kind of excited about them, and I decided to do a project where I wanted to take the core computation that you need to do to train a neural network and parallelize it across one of the sort of 64 processor machines in the department. I thought that would be kind of fun. And because I felt like, if we just could get 64 times as much computation applied to these problems, like maybe they could do interesting things. And so I did a thesis on that. Turns out we needed like 1 million times as much computation as we had, not 64 times. And so neural networks kind of fell out of favor with the whole AI community for 20 years, really. And then only kind of in the late 2007, 2008 timeframe did we start to have, thanks to Moore's law and improvements in semiconductors and so on, did we start to have enough computational power to make neural networks work on real problems. And so I actually bumped into a Stanford professor named Andrew Ng in one of the Google kitchens. He was a part-time consultant at Google. And I knew him a little bit because I'd visited Stanford a couple of times to give lectures. And I said, what are you doing here? He's like, well, I'm still figuring that out. But at Stanford, my students are starting to get good results with neural networks. And I'm like, that's cool. I used to be really, excited about those. I did an undergraduate project on that. And I said, you're getting good results? That's kind of neat. And so we got to talking, and I felt like if we essentially pushed to scale neural networks more than what we could do on a single machine, which is what they were doing at Stanford. If we sort of took lots of machines in Google's data centers and started to train neural networks on those, like the results would probably be even better. A general rule of thumb with machine learning models, and in particular with neural networks, is the larger you scale them up, and if you have sort of commensurate large-scale data sets, the better the results seem to be. And so we started a project around, he and I and a few other people started to play with large-scale neural networks. So I guess getting back into AI was really like returning to something I'd done a tiny bit of during my undergraduate thesis. Although a little bit more from the kind of how do you build practical computer systems perspective, not from the like fancy new machine learning algorithm perspective. You know, I think one of the things that's interesting about neural networks is they've been around for a really long time, and the algorithms that we're using today, you know, some of them are new, but a lot of the core ones are 30 or 40 years old, and they just, you know, took a while to really show their promise once we had enough computation. Sorry, I rambled for a while.
Isaac, you guys are muted.
Yeah, sorry.
Yeah, that was really interesting. Thank you. So let's talk about Africa for a moment. You spent a lot of time in East Africa as a child, and specifically in Uganda and Somalia. You've also done some work to assist some of the issues in the area. So what do you think is the most beneficial application of technology in the area right now?
Yeah, I mean, I think, yes, I had periods of time in Africa as a child. So when I was 5, we lived in the West Nile district of Uganda, which is the very far northwestern corner of Uganda, a very rural area. My dad was doing tropical disease research there. And then when I was 13, we were living in Minnesota in the United States. And my parents were in the Peace Corps in Somalia before I was born. And they both spoke fluent Somali. They would even speak Somali to each other when they didn't want me to understand something when I was growing up. And then, so there was a big drought in 1981, and they said, oh, well, we should go help. So they pulled me out of the last 3 months of 8th grade, and we went to Somalia, spending 3 months in Mogadishu and then 3 months in a refugee camp on the Ethiopian border, kind of near the Juba River. And that was a very, very good experience for me. I felt like, you know, it's obviously much better than going to the last 3 months of 8th grade, because I got to experience a lot of different things. But in terms of, so I've sort of had a fondness for Africa in my heart. I've also spent a fair amount of time in Kenya. I worked in Zimbabwe a little bit for a week or two. And I, you know, we also have started a AI research center in Africa that I was sort of pretty involved in helping start, and it's actually located in Ghana. And so I've spent a little bit of time in Ghana as well. You know, I think in terms of the areas that are really promising for Africa, I think, you know, there's quite a lot of places where sort of machine learning or AI can really help communities of all different kinds. And I think one area is in sort of translation. I think Africa is such a rich and diverse set of languages that are spoken all over the continent, and having the ability for machines to help make content more accessible to people, either English content or other content translated into people's native language, or, you know, translating people's native language to make that more accessible to other people in Africa and the rest of the world. There's a real opportunity there, and many of those, you know, many of the ways in which translation systems work, automatic translation systems work most effectively, is when there's, you know, significant amounts of content that is present in both one language and another, because you sort of then take these what are called bilingual corpuses. So you have documents or sentences in 2 different languages, you know, an English sentence and a Swahili sentence, and you take a lot of those pairs where you know the sentences mean the same thing, and you then can train a machine learning model to ingest those, a neural network, for example, to then ingest lots of that data, and then it can learn to translate new sentences. That's effectively a translation system. And one of the things that we've been seeing is if instead of training a translation system to translate between, say, just one language and another, you instead train a system to translate between many, many languages, like 100 languages, 1,000 languages, and use data from all of those languages, you actually improve the results of the translation quality for all the different languages you translate. And this is, and more importantly, you improve the translation quality for the languages where you have very little data, even more than you improve the translation quality for the ones where you have a lot of data already. Because the system is able to learn from, the commonalities that exist across, related languages, or even sort of fairly distantly related languages, to learn to translate better. And so I think there's a lot of promise in building translation systems that are more effective and better quality, so that we can all, communicate better, understand the world better. I think there's a lot of promise in the area of healthcare. One of the issues with a lot of parts of the world is there simply aren't enough healthcare professionals, not enough doctors. And so if you think about, we've been doing quite a lot of work in how can we build AI systems that can leverage what, machine learning is good at, which is looking at large amounts of data, be it, medical images that you want to diagnose something from that image, or, looking at, patterns of, medical records and trying to predict what are the plausible things that might be wrong with the patient, or what kind of tests might you want to do, where you can effectively assist healthcare providers by giving them sort of an instant second opinion, or an instant way of advising them about what might make sense here. And one way of thinking about that, let's take one of the problems we've been working on in medical imaging is basically looking at retinal images, so images of people's eyes, and trying to diagnose a disease called diabetic retinopathy. So this is a disease that's often sort of a side effect of diabetes, which is affecting more and more people in the world. And as basically, if you're at risk for this, you should really get screened every year. But the screening is sort of fairly sophisticated, and you generally would need a sort of an ophthalmologist, someone with a medical training in eye disease, to look at these images and decide, are these little spots, is that bad, or is that just a shadow, or is that something that we should go get checked out? And the problem with that disease is, if you catch it in time, it's very treatable. But if you don't, then people can suffer full or partial vision loss before they get treated. And so you really want enough screening capacity to screen everyone, once a year that should be screened. And in many parts of the world, there simply isn't enough screening, enough doctors to do the, looking at the images and assessing them. So that's an area where machine learning can really help, because we can effectively take images, retinal images, and those can be labeled by human doctors as, this one's fine, this one's, it's graded on a 5-point scale. So this one's a 3, this one's a 5, this one's a 1, there's a 2. And when you train a model on, tens of thousands of those images, you actually get a model that is as good or slightly better than the average ophthalmologist at diagnosing this. And so then you can take that model and you can spread it all over the world and enable more diagnostic screening to take place than you would if you relied on human doctors to do that. And you also then free up, the few eye doctors that do exist in many of these areas to then actually take care of the patients who do need help. So, those are just a couple of areas I think that are really promising and important. Yeah. We could talk for days about all this kind of stuff.
So still on the Africa topic, Google has numerous initiatives in Africa over the last few years. How do you feel about the progress that's being made? And do you believe that better things are on their way?
Sorry, I missed the last part.
Do you believe that better things are on the way?
Oh, yes. Great. Yeah, I mean, I think in general, the progress in Africa in terms of the economies developing, the countries, becoming sort of education is more accessible than it was, say, 10, 15 years ago in Africa. I think that's super, super great. And Google as a company has quite a lot of African users. The Android cell phone usage is quite large all across the continent, and it's a very mobile-oriented kind of internet sort of environment. And so we definitely have a fair amount of work. I'm excited about the AI research lab that we have in Ghana. We've just leased some new space, and it's got room for growth. So we can see many more people. Some of the work that group is doing is basic research. Some of it is kind of some of the work on like multilingual translation or low resource language speech recognition kinds of things in collaboration with lots of other people at Google. And so I think those kinds of things are going to be useful both in African context but also globally. And so I think we want offices in Africa to focus on problems that are sort of important in that environment, but we also want them to be part of our general research and engineering organization to work on problems that improve or work on things that are important everywhere.
Okay, that seems interesting. Yep. Who's unmuted? I'm sorry. Okay. It's widely known that you're one of the only two level 11 engineers at Google. And what do you think are the makings of a level 11 engineer?
Let's see. When I was pretty lucky growing up to be exposed to computers from a fairly early age, and so I think I have a fair amount of programming experience for someone my age even, and I think being willing to understand computers at lots of different levels. I think one of the things that sort of separates some kinds of programmers from others is they're really thinking about what's going on at all different levels of the stack. What if I write this code, will that run efficiently on this particular kind of machine that I'm working on? But they're also thinking about like, oh, if I'm building something, how will users interact with this system? If I'm building an interface of, some module, how will that interface, need to evolve over time if I'm writing something? But I think it's something that's going to need to sort of have new features added to it. You want to kind of have those in the back of your head, even when you're writing the first version without those features, because all of those things are pretty important. I think the ability to kind of quickly evaluate lots of different alternative ways of solving a problem is a really good skill to have. So, part of that comes from just knowing how fast computers are at doing different kinds of things. Like how fast can you sort a million numbers, or how fast can you read a megabyte file from disk or write it to disk? And with all those kind of low-level things, you can sometimes then estimate, okay, if I solve the problem this way, I need to read the file, I need to read through 100 files like that and then write them back out and sort them or something. You can estimate, if I go with this approach, that's going to take, okay, roughly 20 seconds. And if I go with this approach, it's going to take 1,000 seconds. it doesn't need to be like super accurate. You just want to say, oh, well, I should probably, if it's not too much more trouble, go with the one that's going to be 20 seconds. So that's one thing. I think being able to communicate technical ideas and work with people who have perhaps different kinds of skills than your own. I often find the most interesting projects I work on are ones where you get maybe 3 or 4 or 5 people together, and that you all have kind of different kinds of skills and expertise that are all needed for the kind of problem you're trying to solve. And the reason that's fun and interesting is no one of you could solve this problem on your own, because maybe you have the skills for this kind of thing that needs to be done, but you don't know much about a statistical technique that's needed in as part of the solution. And the great thing about that is, as you all work together to solve the problem, you're each like your own professor for all the other people about your area of expertise. And at the end of it, some of what you know kind of rubs off on them, and some of what they know rubs off on you. And then maybe you continue working together, or maybe you go work on something different. But now you know a little bit more about some other area that you didn't know about. So I think a good lesson is, you don't want to stop learning new things when you finish your university or schooling. You want to kind of be continuously doing that throughout your career. And so try to put yourself in a position where you have some of the skills you need to do your job, but you're always picking up new skills.
Yeah, that definitely seems like the kind of thing that would get you there, I guess. Okay, so I've heard of the JIFTune number, and which is similar to the Beacon number in that it represents the distance between you and a Google engineer in a code review hierarchy. For those of you that don't know, a friend of mine put it as, it's basically the shortest distance for a virus to get to you if it was transmitted by code reviews and it started at Jeff. What would you say is the average JIFTune number for Google engineers? As in, how close are you with the majority of engineers?
I would say probably 3. I don't know. Something like that. I mean, I do a fair number of code reviews, but we have a lot of people. I occasionally will get like a somewhat random code review to like fix a typo in some code that is in some file I touched 15 years ago, but it wasn't my typo, and so I feel like maybe that's not a reasonable thing to do. But but I do take legitimate code review requests to fix other problems.
Yeah, that seems awesome enough. And one more thing, correct me if I'm wrong, but I believe you're a man of routine. And how does a typical day go for Jeff Dean after that 9:07 cappuccino in the morning? And like, is it jam-packed with meetings, public appearances, coding? Like, how does it go?
I'm having it early today.
Okay.
It might even be Ethiopian coffee beans, so I'm happy about that. I think it depends on the day. So I'm actually in this slightly strange state of both running a large research organization. So we have about 3,000 people all across the world in like 44 locations or something. Well, with COVID, who knows how many places we're all in. So that's kind of a lot of what I do, probably 60% of my time. But then I also try to spend about, 30% of my time on sort of technical work, coding. I still do pair programming with my colleague Sanjay Kemawat, who I've been working with for a really long time, even before we both joined Google. Then kind of also doing kind of technical reviews of research work that we're doing in the kind of research organization. So that might be like a review of the work we're doing in robotics research, or the work we're doing in, perception models that run on low power devices like phones or something. So that might be like an hour-long topic review. And, with COVID, I'm working from home, which is different. It feels strange in many ways. I'm sure everyone has experienced a weirdness of the last year and a half that is very different. I'm hopeful kind of the world will get back to a more normal state. But actually working from home has worked out reasonably well for our research organization. I think research work is actually more amenable to working in a very distributed fashion than other kinds of engineering work, where you need a lot of people to be in one place because there's so much communication and handoff of this thing. Oh, is this done? Or how should we solve this problem? Research work is a little less entangled, so you can have like a group of 3 or 4 researchers looking at some problem, and a different group of 3 or 4 researchers looking at a different problem, and they don't need to talk all that often. And so that makes it, and we were very used to already kind of working in a fairly distributed fashion because we have offices in so many places. So that has been a not as big an adjustment for our organization as it has been for others. Sorry, I rambled and I forgot what the original question was.
So let's jump to the A2SP side now. And you've been a huge help for A2SP up to this point. So what are your thoughts on the team and what we do? And furthermore, how do you think AI can assist us in our endeavors?
Yeah, I mean, I think first, I really love what you're doing. I think finding really talented people all over the world and giving them opportunities or advice about what kinds of things that they should be thinking about is really a useful thing. I think this is true all over the world, not just in Africa. Like, I think, for example, in the United States, there's a lot of disparity in the quality of schooling that different people get, and with that comes, a disparity in the opportunities that people have. Some people may go to a high school that has no advanced mathematics classes or has, not very sophisticated science classes, and other people will go to ones that have, 10 advanced mathematics classes you can take. So I think it's really important to make sure that people who don't necessarily have opportunities can be made aware of, what are potential career paths or what are kinds of things that you might want to study that you just haven't been exposed to. And so that, I think, is a great thing that needs to happen more all over the world. And I think what AI can do, I think first it's really helpful for people who are entering the field of software engineering or programming or whatever, to at least have an understanding of machine learning and AI, right? It's 10 years ago, that was probably not true, but I think now what we've seen with the progress in deep neural networks and so on is there's a lot of problems that are suddenly accessible with the use of machine learning that were previously completely unsolved, or very, very, poor solutions existed for things like vision, speech recognition, language translation, language understanding. And so having machine learning as something in your toolkit just broadens the set of problems you can tackle. If you think about what's happened in computing over the last 10 years, 12 years, even the progress alone in computer vision is amazing, right? Like, previously in 2007, computers couldn't see. And then in 2012, they started to be able to see. And in 2016 or 17, they can see in some ways better than humans, obviously not video, but say still image classification. We're actually at superhuman levels at this problem. So we've gone from computers don't have eyes to computers have eyes. And you think about the impact and the kind of difference that makes in what you can imagine computers being able to do, that alone is enormous.
Okay. And as you're aware, we primarily focus on interviews here. So how did you find your Google interview, or did you even have one at the time? And additionally, what do you like about the recruitment process at Google right now? Which parts do you think could use some improvement?
Yeah, so I did have a Google interview. I had several interviews. I remember one person actually asked me to write code on a whiteboard, which is a very weird experience. I'd never written code on a whiteboard. They asked me to implement a arbitrary precision multiplication algorithm. So if you have like two 500-digit numbers or something, how do you multiply them together? And another person asked me about using the link structure in the web to find interesting relationships between pages. And conveniently, I'd just written a paper on this 3 months before that, so I had a fair amount to say, which is good, I guess. Yeah, I mean, I think interview settings are a slightly weird way to evaluate, potential software engineers. They're very, when I interview someone, I usually like to ask very open-ended questions that are more of a conversation. I almost never ask someone to write code on a whiteboard because that's just like a weird thing. But I do think it's important to assess people's coding skills somehow, but there's a lot of ways of doing that. Like if they have, GitHub repositories, you can look at that. If they, if someone else asks them to write code, then I can, ask them about other stuff. So what I usually ask people is very open-ended things that we can take in lots of different directions. So sometime, a while back, I was asking a question like, suppose you could put any software you want on users' computers and in Google data centers. How could you speed up the internet or browsing of the internet, right? And so there's, a lot of different answers to that. You could say, well, you could compress things better and therefore get them to the user computer faster. You could route internet traffic through Google data centers and, try to predict what are the next pages you're going to look at and prefetch those and those kinds of things. And it's just like a thing where we can explore 20 different directions and there's no right answer. It's just like having a conversation as if we're colleagues trying to solve this problem. So that's usually what I try to do. This is not, it's somewhat atypical for what typical software engineering interviews look like these days, I guess. I don't know.
Yeah, that sounds pretty accurate. Finally, our last question with all our guests is, where do you see yourself in 5 years?
5 years, yeah. I hope I am still working on building interesting computing systems. I'm really excited about building a project that I'm working on now is, a lot of machine learning systems today, we say, okay, we would like to solve this particular problem. Maybe it's diagnosing, retinal disease or translating from Swahili to English or whatever. And so we gather data that's applicable to that problem. And then we train a machine learning model to do that thing. And if we're happy with the result, great. If not, we gather more data or fiddle with some things and hopefully make it better. But the problem with that is it feels like that's trying to learn everything about the world and that problem from nothing, right? You literally are initializing the parameters of your neural network with a random number generator every time, and then you start training, and you eventually see enough data and train well enough that it can do this problem. But that model can't do anything else, really. So, and so if you want to solve a different problem, you do the same process all over again. And that seems just completely wrong, right? Like it's sort of like forgetting your entire education every time you solve a new problem. And I think what we want is systems that can actually do many things, right? So this is in the machine learning literature called multitask learning. So you train a model to do 100 things. Like we've seen well, I described earlier, the ability to translate 100 languages at once in that one model actually improved all of them, because it sort of leverages commonalities across the different problems you're asking the system to solve so that they all get better. And that was still fairly narrowly focused on just the task of translation. So now imagine instead of just that, you try to train one model that can do all the things we're trying to train machine learning models to do, right? It stands to reason that that model would be very powerful because it can do a million things. And then the hope would be, as the million and first thing comes along, it can leverage its expertise in all the other things it already knows how to do and be able to do that new thing, with less data. Maybe you only just need to give it a couple of examples of what you want it to do. And it can then find, it's very similar to these other 17 things I already know how to do. And can basically be extended to do this new thing with relatively little data, relatively little computation. And that new expertise in this new task can also then be used for improving all the other tasks sometimes. So, can you build a single system that can do all that? And that's got a lot of challenges at a lot of different levels. It needs like expertise in how do you build really large scale machine learning oriented computing systems? How do you express machine learning models in a sort of compartmentalized way so that you can build lots of pieces of them that get stitched together automatically? How do you, develop new machine learning algorithms that are more dynamically extensible? How do you express the problems you want it to solve? But I'm excited about that. That seems like a good kind of 5-ish year trajectory.
Yeah, it certainly is a very intriguing challenge. Yeah. All right. Thank you very much for your sincere answers. And now we kind of switch roles, and I encourage you to ask any questions, anything that makes you curious, to anyone you want. You can literally see everyone in the class and on the code. If you do have any questions, you can ask them. Otherwise, we can take questions from the other members.
Sure. Let's see. I'd be curious where you're all located. Are you all in Ethiopia or in other countries as well?
Yeah, currently A2SV is in Ethiopia. We're all Ethiopian.
Okay, cool.
Yeah, right now we're actually in the campus of Addis Ababa University, as in the class we're in.
Very nice.
And this September, we're actually expanding to another university in Ethiopia. And by 2022 September, we will also expand to Tanzania. So
Okay.
That's the key.
Cool. Wonderful.
Do you have any other questions?
And I guess, what is the typical way in which one of your students decided that they were interested in computing or software? Maybe there is no typical way.
Yeah, that sounds like a good question to pass on to one of the audience members, I guess. Anyone want to take this? Go. No. Yeah. All right. I will respond.
So, hey Jeff, my name is Abel and I'm a PhD software engineering student. So personally, I was really interested in computing and software engineering because it was really dynamic. I was really into the dynamic environment, so I wanted to explore and get to know new things from time to time. So that was one of my main reasons why I joined software engineering, and I really found it really interesting, and I also found out that it was one of my biggest passions. That's my major reason. Thank you.
Yeah, me too. I think one of the really amazing things about software is that it's so quick to take something you imagined in your head and turn it into something sort of tangible and real, right? And it has this amazing ability that a small team of people can do something, and then your work can be used by lots of people, right? You know, be it you create something and then, you know, 50 of your friends use it. It could be, you know, you're working at a company and so lots of people, lots of customers are using it or whatever. But that ability to take what you've done and then instantly make copies of it or make it accessible to so many people is something that is really unlike most professions, right? It's very hard to, as a doctor, scale yourself so that you affect tens of millions of people. Or if you build physical things, you know, it's just very hard to, well, first the iteration time is very long, and then it's very hard to also affect, you know, tens of millions of people. So I feel like software is this amazing thing where, you know, a small group of people can do something that everyone in the world can use, or a lot of people can use, which is kind of cool.
Yeah, and thank you, Abel. All right, if you have any, that's good. But if you don't, I think we should take some questions from the team members. Awesome. Like, anyone have any questions?
Hi, Jeff.
Hello.
My name is Gamacho, and I'm a 5th year software engineering student. So I have two questions. One very important, and the other actually not important. So the not important question is, take us back to when you were at school, and what's your typical day look like, and which of your habits back then have contributed to the person you are today. And very important question is, what the thing behind you? Yes.
It's art. It's maybe hard to tell, but it's a little fuzzy green astronaut. I just thought it was cool, and the room was kind of bare otherwise, so we got it.
Yeah.
We have nicknames for him or her. One is Mosstronaut, because it looks kind of fuzzy, like it's covered with moss. Another is AstroTurf, which is the name for like fake grass you see on like sports fields sometimes. But my favorite is Fuzz Aldrin, which is Buzz Aldrin was one of the first astronauts on the moon. But he's Fuzz Aldrin. So the other question was, what was my schooling like, and what was I like in school, I guess, sort of. Yeah, I had a very unusual childhood, I guess, in that we moved around so much. You know, I mentioned living in Uganda and Somalia, but I also lived in lots of other places. And so I ended up going to 11 schools in 12 years, which is, you know, quite a lot. I was always the new kid. And you know, I think that meant I got to experience a lot of different ways of teaching, you know, because each school was a little different in how they approach, you know, teaching math, or like how you handle, you know, organizing kids to go to recess or whatever. And so I got to, I feel like, experience lots of different things. And I often found that I really enjoyed reading. So I would like go to a new school and I would try to quickly find the library and read most of the books in the library or something. And, you know, reading all different kinds of things, fiction, nonfiction. And then later I got into programming. And so I would then, you know, spend a fair amount of time not doing homework I should have been doing and writing code that I found more enjoyable. So I didn't have very good grades, but I did write a lot of code during high school and middle school. And that probably has served me well. I don't know, you know, I have really great memories of a handful of teachers. I think in anyone's education, there's like just a handful of teachers that really stand out as people who've taught you a tremendous amount or have approached teaching you as an individual in a particular way that really worked for you. And so I think that's something I find, I still think back on a particular teacher sometimes and like, oh, that was something I learned in this way. That was great.
Yeah, that all sounds awesome. And I think particularly on the part of coding instead of doing a lot of homework, some of our members could relate to that.
Yeah, a strategy for not particularly great grades is to do the homework you're interested in.
Exactly.
But not do the homework you're not interested in.
That makes sense. Okay, I'm sorry this went a little over time, but I hope you're having a good time at least. And thank you very much for spending your time with us. Yeah, that's
of course. Thank you all for spending your time with me. And it's been a delight chatting with you. And good luck in your studies and all the things you're trying to achieve. And stay healthy.
Awesome. Thank you very much.
Thank you so much.